Our project examines the effects of chrysin and PCA on an MPTP-induced Parkinson's in zebrafish. We will look at the behavioral symptoms caused by the damage done to the dopaminergic neurons. Parkinson's is a disorder of the central nervous system. It is caused by a shortage of dopamine-generating cells. The most common symptom is tremors, usually of the hands. It is incurable, but treatment often helps. There are 200,000 to 3 million cases per year in the U.S. alone.
Chrysin and PCA are neuroprotective agents that have been proven in several studies to repair dopaminergic neurons and improve symptoms characteristic to Parkinson's. Essentially, we are going to simulate Parkinson's in zebrafish using MTPT and observe the effects of chrysin and PCA. For our experiment, we will be using zebrafish embryos, an incubator, MPTP, a penicillin streptomycin antibiotic compound, chrysin, protocatechuic acid, or PCA, sterilized 24-well plates for embryo culture, and up to 5 fish tanks separate from the aquaculture fish system to conduct experiments in house PD fish.
Our budget totals to about $600 including shipping and sales tax. We will need 2 orders of total, 10 milligrams of MPTP costing $90, penicillin streptomycin costing $23, PCA costing $146, chrysin costing $108, saline solution costing $15, 24 well plates costing $25, and plastic fish tanks costing $50.
The following protocol has 6 phases.
Our first step will be creating stock solutions. We will need to create chrysin and PCA solutions, MPTP solutions at different concentrations, and Holt-Fretter solution.
After getting the zebrafish embryos, we have to introduce and adjust them to a neutral environment, which we will simulate using Holt-Fretter solution and an incubator set to 28 degrees Celsius. From there, we'll divide up the viable eggs into control and experimental groups.
Next, we will induce Parkinson's by applying MPTP solution containing Holt-Fretter solution, MPTP, and penicillin streptomycin to the embryos. We will then wait 3 days for them to mature.
For our experiment, we will have 1 control group and 3 experimental groups to see the effects of each neuroprotective agent individually and together.
Then we will observe the behavior of the zebrafish. We will test each fish's reaction time by prodding it with a sterile loop. Hypothetically, the fish that benefited the most from our treatment will react more quickly in comparison to the fish that received no treatment.
Ideally, we will also have time to collect more quantitative data from sacrificed zebrafish by measuring the amounts of free radicals released due to oxidative stress caused by Parkinson's in zebrafish, using gel electrophoresis.
Our timetable is very spread out. Before Thanksgiving break, we will finish preparation of our stock solutions. By winter break, we will have our first MPTP trial complete so we can adjust quantities and concentrations accordingly with our results. We will begin our experimental trials with our neuroprotective agents on January 12th after winter break. We plan to finish our observational trials before February 21st and our experimental trials before March 2nd. Parkinson's is a poorly understood disease. Symptoms manifest differently in every patient, but that does not mean Parkinson's patients are hopeless.
Drug treatments like PCA and chrysin can improve symptoms and quality of life by repairing the damage at the source.
That concludes our presentation.
Thank you for watching.